Section 9.2, Solve quadratic equations by using the quadratic formula. So in the previous section we learned how to complete the square, we reviewed the square root property, and a little bit of factoring. In 9.2 we want to use the quadratic formula for all of the problems. Now the quadratic formula is derived by completing the square on ax squared plus bx plus c equaling 0. I won't show that to you, but it is in the book if you want to see it. So the quadratic formula is x equaling opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So again, make sure you start off with the quadratic formula being x equals. You do need to have that very first part. Don't just start off by saying opposite of b. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So to use the quadratic formula, the best thing to do is to get rid of all fractions. If you want to get rid of decimals too, you can, but definitely get rid of fractions. Combine like terms and bring everything over and put it into the form of ax squared plus bx plus c equaling 0. Once you get it into ax squared plus bx plus c equaling 0, you then know what a, b, and c are, and then you can just plug it into the quadratic formula. Solve using any method possible. Number 1. X squared plus 5x minus 6 equals 0. I gave you the option to use any method you would like. So the first method I would try is to factor. Are there factors of negative 6 out up to positive 5? Sure, they factor into x plus 6 times x minus 1 equaling 0. So then I said each factor equal to 0 and solve, and I get x equaling negative 6 and x equaling positive 1. So I didn't have to use a quadratic formula there. If you want to try using the quadratic formula, make sure you can get to the answers of negative 6 and 1. Now looking at number 2, we have 3y squared plus 10y minus 8 equaling 0. If I wanted to factor that, I would have to do the AC method, where I start off by multiplying a times c. This one actually is factorable, but some students don't really like using that AC method so much, so let's go ahead and try the quadratic formula instead. We know that a is going to be 3, b is 10, and c is negative 8, because it's already in the form where everything is over to the left-hand side and it equals 0. Now we're not going to say x equals, we're going to say y equals, because that's the variable I'm using. So y equals the opposite of b, so negative 10 plus or minus the square root of, I need to take 10 and square it, use parentheses, minus 4 times a, which is 3, times c, which is negative 8, all over 2 times a, and a is 3. So then we get y equaling negative 10 plus or minus the square root of 10 squared is 100 minus 4 times 3 times a negative 8 actually gives you a plus 96 all over 2 times 3 is 6. So we end up with negative 10 plus or minus the square root of 196 all over 6. Well, there is a nice square root of 196, it's 14. So this is going to turn into, I'll just come up here, y equaling negative 10 plus or minus, we said the square root of 196 was 14 all over 6. We can't stop there. Because of our radical completely disappearing, we should be able to go into two different answers. When we take negative 10 and we add 14 and divide by 6, and the other answer is when we take negative 10 and we subtract 14 and divide by 6. So negative 10 plus 14 divided by 6 is a positive 2/3, and negative 10 minus 14 divided by 6 is a negative 4. When your radical completely disappears in your final answer, that means it was factorable from the beginning. So if you wanted to try the AC method, you should be able to get to y equaling 2/3 and negative 4 as well. Number 3. A squared plus 4a plus 1 equals 0. If we try and factor that, it's not factorable. There's no factors of 1 that add up to 4. So we definitely have to use the quadratic formula or completing the square. Well, looking at our quadratic, we do see that everything is over to one side and it does equal 0. So our a is going to be 1, our b will be 4, and our c will be 1. So let's write the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And now we'll plug in our numbers. So a equals, because that was my variable that I was using, so a equals the opposite of b, so -4 plus or minus the square root of, then I need to take 4 and square it, use parentheses, minus 4 times a is 1, times c is 1, all over 2 times a, and a is 1. So a is going to equal -4 plus or minus the square root of, well, 4 squared is 16, minus 4 times 1, which is 4, all over 2 times 1, which is 2. So a is going to equal -4 plus or minus the square root of, 16 minus 4 is 12, all over 2. So let's do the factor tree and see if any number can come out of the 12, and that's 6 and 2, and 6 is 3 and 2. So I do have a pair of 2's. So a is going to equal -4 plus or minus a 2 comes out, a 3 is left, all over 2. Now here's where a lot of students go, can I cancel, can I not? So here's my suggestion. Always break it up into two separate fractions. -4 over 2 plus or minus 2 square root of 3 over 2. Now at that point, if you can reduce, go ahead. If you can't, you are done. So reducing that, we get a equaling -4 divided by 2 is -2, plus or minus the 2's cancel, and I get square root of 3. So a is going to equal -2 plus or minus the square root of 3. So separate your answer into two separate fractions and then reduce if you can. Number 4. 3x squared plus 9 equals -8x plus 2. This is quadratic because we see the x squared, but it's not in the right form to use the quadratic formula. I need to add over the 8x and subtract over the 2. So I'll get 3x squared. When I add over the 8x, I get plus 8x. But when I subtract over the 2, 9 minus 2 is 7, so I get plus 7 equaling 0. I could try the AC method, but in this section, sometimes factoring is not going to work. And so I'm going to go ahead and use a quadratic formula. I already know what A is. A is 3, B is 8, and C is 7. So plugging this into my formula, I get x equaling opposite of b, so -8 plus or minus the square root of 8 squared minus 4 times 3 times 7 all over 2 times 3. So I end up with -8 plus or minus, well, 8 squared is 64, and 4 times 3 times 7 is 84, but it's going to be a minus 84 all over 2 times 3, which is 6. So that's going to give me a -8 plus or minus the square root of -20 all over 6. So the negative under the square root means there's going to be an I, and what else can come out of a 20? Well, 20 is 4 times 5, and 4 is 2 times 2. So a 2 is going to come out and a 5 is going to be left underneath. So I end up with x equaling -8 plus or minus 2, an I comes out, a 5 is left underneath, all over 6. So just like in the previous problem, I say separate and then we can reduce. So -8 over 6 plus or minus 2 square root of 5i over 6. I'm going to put the I at the end. When I reduce -8 over 6, I get -4 over 3, plus or minus, and then the 2 over the 6 can be reduced as well, so I get the square root of 5i over 3. So x equals -4/3 plus or minus the square root of 5i over 3. Again, make sure that I is outside the radical, either at the end or at the beginning. I'll accept either, but it really should be at the end. Number 5. 2x squared plus 10x equals 0. Again, the directions say solve using any method. Well, I see a GCF, so I'm going to factor out the greatest common factor, which is a 2 and an x, and I'm left with x plus 5 equaling 0. So it's factored, it equals 0, so then I set each factor equal to 0. So either 2x should equal 0, or x plus 5 should equal 0. I'll divide by 2, so one of my answers is x equaling 0. I'll subtract over the 5, so x equals -5. So my two answers are 0 and -5. If you want to try quadratic formula, A would be 2, B would be 10, and C would be 0. But factoring is a quicker method there. Number 6. 1/5 x squared plus 2 equals 1/2 x. If I want to use a quadratic formula, the best thing to do is to get rid of fractions. So I need to find my LCD and multiply every term by it. So the first number 5 and 2 can both go into is 10. So my LCD is going to be 10. So what I'll do is I'll multiply every term by 10 over 1, so therefore my fractions will cancel. Well, 10 times 1 is 10, but divided by 5 is 2, so I end up with a 2x squared. 10 times 2 is 20, so I get a plus 20. And 10 times 1 is 10, but divided by 2 is 5, so I end up with 5x. So then I need to subtract over the 5x, make sure you put it in descending order, so that needs to go in the middle, and I'll end up with 2x squared minus 5x plus 20 equaling 0. If you want to try the AC method, you could, but again, in this section, not everything is factorable, and this one's not factorable. So let's go ahead and use a quadratic formula with a being 2, b being a negative 5, and c being 20. So x equals the opposite of b. Well, b is negative 5, so it's going to be positive 5. Plus or minus the square root of negative 5 squared. Use parentheses because that negative is being squared. Minus 4 times a is 2, times c, which is 20, all over 2 times a, and a is 2. So x is going to equal 5, plus or minus the square root of, well, negative 5 squared is a positive 25, 4 times 2 is 8, 8 times 20 is 160, so it's a minus 160, all over 2 times 2, which is 4. So x is going to equal 5 plus or minus the square root of 25 minus 60 is negative, so we're going to have a negative under the radical, and we end up with 135 all over 4. So x equals 5 plus or minus the square root of negative 135 all over 4. Well, negative 135 has a negative underneath, so we're going to have the I, and 135 can be broken up into 5 times 27. Well, 27 can be broken up into 9 times 3, and 9 is 3 times 3. So I do have a pair of 3's that's going to come out, and this 3 and this 5 are going to be left underneath. So we'll end up with x equaling 5, plus or minus, we saw that a 3 came out, an I came out, and 3 times 5 is 15, staying underneath, all over 4. Separating those into the two answers, I get x equaling 5/4, plus or minus 3 square root of 15, I at the end, over 4. So this one was not factorable from the very beginning, so definitely either need to use quadratic formula or completing the square. But I would think about getting rid of fractions first. Number 7, x squared minus 81 equals 0. If you want to use quadratic formula, you can, but this one is factorable because it is a difference of squares. Factors into x plus 9 times x minus 9 equaling 0. So x would equal negative 9 and positive 9. So you could actually use quadratic formula with a being 1, b being 0, and c being negative 81. But that is a longer method. The other method you could hopefully pop into your head is the square root property. Add over the 81, and then take the square to the left and the square to the right, not forgetting plus or minus. So we end up with plus or minus 9 as well. So either of those methods work the quickest. Number 8, we have x minus 3 times x plus 1 equals negative 6. Well, this kind of looks like it's factored, but it really would not be able to be solved unless it equaled 0. So at this point, we do need to multiply all that out. So x times x is x squared. Outer gives me a positive 1x. Inner gives me a negative 3x. And last gives me a negative 3 equaling negative 6. Combining like terms, x minus 3x is a negative 2x. I'll add the 6 over to the other side, so I get a plus 3 equaling 0. So we get x squared minus 2x plus 3 equaling 0. Some students are going to jump to factoring, but the signs really do not work. The factors of 3 that add up to negative 2 do not exist. The only factors of 3 are 3 and 1. If we make the 3 negative, then when I multiply, I don't get a positive. So no matter how you try, it's not factorable. So you definitely want to use quadratic formula with a being 1, b being negative 2, and c being 3. So plugging it into the quadratic formula, I get x equal the opposite of b. Opposite of negative 2 is positive 2, plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is 3, all over 2 times a, and a is 1. So x is going to equal 2 plus or minus the square root of negative 2 squared is a positive 4. 4 times 1 times 3 is 12, so minus 12 all over 2 times 1 is 2. 4 minus 12 is a negative 8, so 2 plus or minus the square root of negative 8 all over 2. What can come out of an 8 is a 4 and a 2, and a 4 is a 2 and a 2, so I do have a pair of 2's. So x is going to equal 2 plus or minus a 2 comes out, an I comes out, a 2 is left, all over 2. Separating these, we get 2 over 2 plus or minus 2i squared of 2 over 2. So 2 divided by 2 is 1. It does not disappear. You have a 1. Plus or minus, again, 2 divided by 2 is 1. And so you're going to have square root of 2, and I'll put the I at the end. So my final answer is x equaling 1 plus or minus the square root of 2i.